Hello, Devox. After 3 years, it's so good to be here and such good vibes. Seeing these rooms filled again with Java fans. Are you happy to be there, Remi?
Yeah.
Are you happy to be there?
Yeah. More!
Come on. Are you happy to be there? Devox again. It's so good to be here. So, all right, welcome to this session. We are going to talk about Loom. Loom is blooming, Remi, because we have an official preview version of Loom in the JDK 19. I guess that everybody is aware that the JDK 19 has been released back in September. I know that some of you are still running Java 8. Who is running Java 8 still? Oh my God, it makes me so sad. I really feel the pain for you. I'm so sorry. You know that running Java 8 as of today is just like running Java 5 when Java 8 was released, because Java 8 will turn 9 years old, right, in next February. And now you're not laughing anymore, of course. All right, my name is José. I now work at Oracle in the Java platform group as a Java developer advocate. Yes, I joined the dark side. And here's some link with some stuff I'm publishing on the web, in case you're interested in that. And we are doing this talk together with Remi. And Remi is the guy on this picture.
And and I'm working on a lot of Java spec things.
And you don't work for Oracle. It's written.
And I don't work for
Oracle.
Oracle.
It's written here. Along with the JDK 17 that was released last year, and is probably the version you're most interested in, we also released a website called dev.java, which is the official website with the Java documentation in it, if you want to check it out. It's regularly updated. The previous website was not so regularly updated, but now there's someone in charge, so hopefully it is. And there are community pages. Now, if you're running a jug or a local event in your communities, and you're not referenced on the Java user group page of this website, and you want to be referenced there, you can just send us an email, and we'll gladly add your jug on it. And also, there are several Java Day that have popped around the world. So if you want to organize an event called Java Day in your local community, once again, just talk to us, send us an email, and we'll gladly help you and explain you how you can do that. And if you're not in videos, if you don't like YouTube, and if you don't like this kind of thing, you can also listen to us on the Inside.java podcast, which is a podcast that it goes quite deeply into technical details. So if you're also reading this kind of thing, this podcast is really worth checking out. Before we really start, Loom is a work in progress. It's still a preview feature, which is on the one hand, it's nice because you can take it, you can try it, you can report bugs if you find bugs, report missing features if you find there are missing features on the Loom mailing list. Before it makes it as a final feature in the JDK. But it also means that everything that we're going to talk to you about this morning is subject to change, of course, obviously. There are 2 JEPs currently about the Loom project. The first one is about virtual thread, and that's going to be the first part of this talk. You can see that the effort is an XL effort. If you check the JEPs, there are not that many JEPs that are an XL effort. And my friend David Delabasse couldn't make it this week, by the way, which is really sad. Just tweeted about the pull request for this JEP. Okay, I guess you all know what a pull request is. I guess you all know what reviewing a pull request mean. Okay, so this pull request has been reviewed. There was something like 100,000 lines modified in the JDK by the introduction of virtual threads, which is not a small thing. And the second JEP we're going to talk about is the structured concurrency JEP, which is also a preview feature. Technically speaking, it's called an incubator API, so it's not exactly the same thing, but it just means that it's not in a final state. It's still also a preview. And actually, there's also a third part called ExtentLocal variables, which didn't make it to the JDK as a preview feature in the JDK 19. As of now, it's still a candidate JEP, so if it makes it as an incubator feature, it will be made available in the JDK 20, which is bound to be released in February or March or something.
In 6 months.
Okay, 6 months, thanks to this new release cadence. Great. So if you have any feature that you think that are missing, bugs to report, blah, 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 you can go to this page, jdkjava.net/loom, where you can find everything you need, including documentations, early access build of the Loom branch of the JDK, and of course the mailing list, where you can have all the details you need. Right. So Loom is about concurrent programming. Concurrent programming is something we love. It's so easy to program a concurrent application, and so easy to fix the bugs that you have in concurrent applications. Yes, it's an endless job to do that. In fact, in 1995, Java was one of the few languages to have a concurrent programming model embedded in the language and embedded in the standard API. You could write runnables. That was before lambda expressions, of course, so you had to make an instance of an animals class, and you could give this runnable to a thread, start it, join it, and that was it. The book you were bound to read was this one. It's a little dated now, but there are still very good ideas in it, so it's probably still worth reading, I would say. Sometimes I like to read one page of another. All right, and if you want to do synchronization, this is the only pattern you have, synchronized of key, to make sure that this line of code is not executed by concurrently by more than one thread. Great. And then nothing much happened until Java 5, 2004, with the release of the Java Util Concurrent API, which brings a new model for the task you can run in your concurrent application called the callable. The callable is nice because it can speak to you. Okay, it can produce a result and it can throw exceptions. When you're doing I/O in your concurrent stuff, it's quite good to have that. The book you need to read is this one, which is still the up-to-date book. Well, not really up-to-date because it's a little dated also, but there are so many good ideas in it.
Oh, all the principles have not changed.
Yes, the principles are still right, but there are still missing things that are that would be interested to be that are not covered because they were not here, they were not there yet. But it's still a book really worth reading anyway. You have this executor service pattern that is added to Java Util Concurrent. And we're talking about that because we're going to talk more about executor services in the rest of the presentation. Basically, an executor service is a pool of threads. You submit tasks to it, you get a future as a result, and the threads that are in it are kept throughout the life of this executor service. That is, in the previous pattern, once the thread is done, the thread dies, so if you need another one, you need to create another one. Here, your threads are pooled because threads are precious, they are expensive to create. So this is why you have this executor service. You are not supposed to run your thread by hand, new thread of task. You're not supposed to do that anymore. You're supposed now to use this executor service stuff. This future object is really simple to use. Get, cancel, you can have a timeout. It got some attention with Loom. We're going to see that in the second part of this talk. All right, and you have many primitives in the APIs of Java Util Concurrent to do synchronization without relying on the synchronize keyword. Here's the reentrant lock, and you have more, especially in the collections framework. All right. And then there is another step up to the JDK 7 and JDK 8. So that's 2014 for the JDK 8. In 1995, 2004, 2014, there's some kind of pattern happening here. Every 10 years, something is happening in the Java concurrent space in Java. And here you have the introduction of two things. The first one is the fork join framework. The fork join framework is what enables the parallel streams. It's very technical to use by hand, I would say. And it relies on a special pool of threads that is different from the executor service, and that is the fork join pool. The main difference with the executor service, between the executor service and the fork join pool, is that in an executor service you have one single queue, one single waitlist for all the tasks that you're submitting to this executor service, whereas for the fork join pool you have one waitlist per thread. Every thread has its own waitlist, and if a waitlist becomes empty and the thread doesn't have any more tasks to execute, it's able to go to the other waitlist and get some tasks for that. This pattern is called the work stealing pattern, and by the way, it is described in Brian's book, Java Concurrency in Practice. And the second element you have in the completion stage, in Java 8, is this completable stage, completable future API, which is the model the JDK brings for asynchronous programming. Now, it's also quite a technical framework, but it's also very rich. There are many things in this framework. Over these 3 iterations over the 15 years, there is one thing that stays the same, which is once you have submitted a task to a thread, there is no way you can detach this task from this thread. Either this thread will be interrupted and this task will be broken, or the task will complete either normally by producing a result or exceptionally with an exception. But there is no way you can say, okay, I want to take this task, free this thread of this task, and do something else with this thread. This, you cannot do it. And this is precisely what Loom is going to enable, well, is already enabling in its preview feature. So 2022, maybe we will have the final version in 2023. Who knows? That's still possible. We have Loom. So every 10 years, there's something happening in the concurrent space on the Java platform. Why do we need concurrency? Well, that's a very important question to answer, because if we realize that we don't need it, then it will make our application so much simpler. Yeah. We need concurrency in 2 use cases, 2 main use cases. The first one is parallel programming based on concurrent programming. That is basically the parallel streams. Okay, you have a big stuff to compute, like a big array to sort, and you want to split this array into subarrays, sort them in all the cores of your CPU, and then merge the results. All right, this is basically what the parallel streams are doing. And what you want to do is really use 100% of your CPU, of all the cores of your CPU. Now, the problems you have with this kind of thing are algorithm problems. Okay, you should not expect, if you have 8 cores or 12 cores, you should not expect to gain a factor of 8 or 12 for your application, because the algorithm you're going to use in parallel is not the same as the algorithm you use when you're computing your stuff on only one core. For the sort algorithm, for instance, you need to split this array, that's an overhead, and once every subarray has been sorted, you need to merge sort everything, so that's an algorithm that is not used in the first place when you're not using parallel stuff. So that's a different issue. This kind of use cases, Loom is not addressing this kind of use cases at all. Don't use virtual thread to do that. It will not bring you anything. Okay? Loom is really addressing the case of blocking threads. All right? For instance, you have a web server or a database server, and you want to have one thread per request, one thread per transaction. This is the kind of use case Loom is trying to address. Let us zoom in on this one a little more. You see, suppose we are doing a request on the web. The first thing you need to do is to prepare your request. You need to prepare the URL of this request. You need to prepare your parameters, everything, security. This is happening in the memory of your application, and the time scale at which your computations are conducted is the nanosecond. It will be in the order of 10 nanoseconds. All right? Then your request is ready. You're launching this request on the web, and then you change the time scale. It's not nanoseconds anymore, it's milliseconds. That's 1 million times longer than the nanoseconds, the factor of 1 million between both. All right? And then you get the response. You have some strings to decode, some JSON to decode, etc. This is again in-memory computation. So this is again in the order of the nanoseconds. Okay? So if you check all the stuff, you have nanoseconds, milliseconds, nanoseconds. Actually, this sketch is not at the right scale at all, because if you have, let's say, 1,000 pixels in the width of this slide, it means that you will have 1,000 pixels for the millisecond part, for the red part, and 1,000th of a pixel for the green part. So the green part is in fact invisible on this sketch. Okay? There's a 1 million factor between both, which is a lot. All right. So how many threads do you need to keep your CPU busy? That's the question. Because in this kind of thing, if you're running this on a single core, then your core is used basically 0% of the time. You will not see your core working at all. So you bought a very expensive CPU and you're basically not using it, which is a pity. You could have saved money, right? Well, it's quite easy to answer this question. If you want to have your CPU busy 100% of the time, let's say between 90% and 100%, you need 1 million threads. 1 million threads. I don't know if you ever tried to launch 1 million threads on your machine. We did. Okay. The problem is that a thread is not cheap. It takes about the thread class in a JDK is in fact a wrapper on an operating system thread. And launching such a thread takes about a millisecond. All right. So 2 million threads, that's 1,000 seconds, roughly 20 minutes, which is a lot when you're doing some web requests. And it consumes about 2 megabytes for the stack of this thread, which means times 1 million to terabytes of memory. I do not have terabytes of memory on this laptop, so I cannot show you. If you need a terabyte, you probably need to pay quite some money to do that. And context switching is also super long. So that's why all these solutions, completion stage, completable future, and all the solutions around asynchronous programming have been developed. All right, to precisely save on that. All right. So what are the problems with these kind of solutions? Because we've all been using them. Well, if you don't know what callback hell is, I invite you to type this in your favorite search engine. And you probably already know what is an application based on callback within callback within callback within callbacks. Okay, it gives you code that is not super simple to read, and probably also quite hard to write.
Yeah, it's spaghetti-oriented code.
Spaghetti-oriented code. I know we have Italian people in the room, so we shouldn't make fun about spaghetti. By the way, I love spaghetti as well, but not in my code, really.
I'm half Italian.
If you have you're half Italian. Didn't know that. Okay, good to know. So you only half of spaghetti. So all right. If something crashes in your application and you have your call stack, your 1,500 lines of call stack, it will not help you much because you have the framework and not really your application in this call stack. It's super hard to write unit tests for this kind of thing. In fact, it's not really unit test, and you will, if you're not super cautious, you will have race conditions in your tests. That may be an issue. And I said hard to profile, but it's in fact impossible to profile.
Yeah, you just can't. There is no tool to profile an asynchronous call.
Yeah, absolutely. So this is what Loom is aiming to address, is aiming to fix. All right? And this is where you are going to show us virtual threads.
Yes.
You need a place. I need to remove my laptop. No. Okay, so we are going to switch off this stuff.
And it doesn't work. Great. So, yeah, it's just a simple example on how to start a thread. So I suppose you all know how to start a thread. And so you can see when you print a thread here that you have the number of the thread and the thread group, basically. So here we will introduce a new concept now you have a builder to create thread, because basically what Loom is provided is another kind of thread. So here you have a builder named off platform that return a thread builder, this kind of a thread.builder things here. And I can configure it and call start on it. It will just run as a platform thread, and instead of off platform, you can use off virtual that will return another thread builder, a different kind of thread builder, and you can start a virtual thread. That's all. The API is exactly the same. The idea is if you change the kind of thread, all the existing code will still work that way. You can see in the that the toString is slightly different. It's a virtual thread here. You have a global number, and you have this slash something, which is a virtual thread run on a platform thread. And yeah, if you want to debug it, you can see the platform thread used by the virtual thread at a moment. You can see a fork join pool here. This is not the common pool. This is another pool which is specific to the virtual thread. Basically, when you start one thread, Loom will create a fork join pool of thread. You have one platform thread per core, and all the virtual thread will be scheduled on this fork join pool. The main difference between the common fork join pool, the one used for the parallel stream, and the one used for the virtual thread, is that this one is first in, first out. The common pool is so first in, last out. So the question is, how many platform thread, you can see here, how many platform thread I can run on my laptop. This is macOS, and macOS is very specific. When you create a thread, it will fully reserve the stack. It's not like in Windows or with Linux, when you have a kind of overbooking, which is it will say, oh, it's virtual memory, and when I will need the stack, I will try to give it or just fail. In case of macOS, it fully reserve the memory. So if I run it, I try to...
That was quick.
I try to create 10,000 threads, and I just run out of memory. I can just print the index so I can see how many threads I can run, and I can run something like 4,000.
Yeah.
Basically, it depends on my memory, the memory available. Because each thread takes 2 megabytes of stack, you can just divide and you know how much thread you can start. So the idea is to see with virtual thread. So it's exactly the same code as I've just changed the builder here. And I will run it, and it seems to work. Yeah.
So you could launch 10,000, right?
Yeah. No? Okay. let's say 1 million.
Oh, come on, it cannot work.
This is what we want. And it will take some time. I will explain why. So it should take 2 seconds. It takes more, something like 6 seconds. But I can run 1 million threads. So why it takes far more time than it should? It's because of this, which is when you have 1 million thread. If you take a look, this is stored in an array list. We have the two lists. Technically, it's not an array, but in a list. And here I will call each thread. I will call join on each thread, but the thread will not stop in the same order as the order I'm trying to fix here. So basically, by joining the thread in this order, I'm forcing the scheduling to be different. And the 3 minutes, the 3 seconds, you have the difference is because I'm trying to force a scheduling order on this. We will see in the second part of the presentation that we can do better than just a join like this. So let's see another example. I have an atomic integer here. It's just to count something. And I sleep 1 second here. And here I have 4,000 virtual thread, but I will only print 1. The 10th one. And I will do exactly the same, take the time and write the counter and the time. What you can see is something quite fun, which is my virtual thread 32 starts running on the platform thread named worker 4, but when sleeping, after sleeping, this code runs on the platform thread 8, which is kind of funny, because the code switch between OS threads, between platform threads. So that's the main difference. That's what Loom provide. Loom provide a way to not stop a platform thread when you are doing a blocking call, a blocking system call. What Loom does is to basically do something that I can show you. So here I'm cheating a little bit. I'm using a class named continuation, which is in JDK internal VM continuation.
Isn't it forbidden to use these kind of classes?
It is, but there is some magic thingy you can. We can try just to run and see that I have an illegal access error saying, oh, you cannot use this. But if I add this line and say, yeah, it's not a problem, I will expose JDK internal VM to all modules, all unnamed modules.
Don't do that in your production environment.
No, right? No. It's just for fun. It's just here. And I don't know how...
You can click on the range.
On the range. Oh, yeah. Thank you. So here I will add a VM option and this apply, okay, and run, and it runs. So let me explain what it does. I have a continuation scope. Let's say it doesn't exist. We don't care about it. So we have a continuation object. A continuation object is something that takes a runnable and just run it. And there is a special static method called yield that you may know as a keyword in other languages that allow to give back the end, give back the running. I don't know how to call it, but you basically say when I use continuation.run here, I will run the code until there is a yield. And the yield will give the end back to this code. You can note that there is no thread here. Everything runs on the same thread. It's just that I have the ability to stop a computation at some point, and I can call continuation.run again to resume the computation. So here you can see that I will print start here, call continuation.run, that will print C1 here, yield will go there, print came back, and continuation.run will restart just after the yield here, print C2 goes back here, and print done. So this is not a public API you can use. There's some trouble if you try to use it because the JIT doesn't like this kind of code, and basically if the JIT does some optimization here, he will try to reuse it here, even if it's perhaps not on the same thread or things like this. So that's why it's an internal thing and not something you can play with. But it's to we want to show it because it's a nice way to explain how it works internally. So how it works, it's quite simple. When you do a yield, you will take the whole stack and copy it on the heap. And when you come back from a yield, you will take the stack on a heap and copy it back on the stack. Maybe it will be at another address on the stack. Maybe you will have some stack frame in between or things like this. Because here I am calling continuation.run in the same main method, but I will be able to call several methods that call continuation.run, which means that basically I have not, when I come back, it's not the same address on the stack. We can do that in Java, because in Java we have no pointer on the stack. That's the main difference between Java and C. With C or with Go, let's say with C, you can create a pointer on the stack. So you cannot move the stack around or you will be in big trouble. So this is something we will see in a next following example. So if I come back to my example of thread.sleep, I can just take a look to the code and goes to the rabbit hole. And you can see this kind of thing, which is really great for two things. First, it's a new syntax. I don't know if you know it. It just means it's an instance of, and it does the cast just after and stores the result in this variable, which is quite nice. And the other thing is that the JDK has been changed, has been revamped to support virtual thread, which is for every blocking call that you have inside the JDK, you have code that will check if the current thread is a virtual thread or not. And if it's a virtual thread, instead of blocking the platform thread, it tries to deschedule itself, deschedule the virtual thread. So it calls sleep nanos, and sleep nanos call do sleep nanos, or do sleep nanos here.
It's the same.
Yeah, it's the same. It depends if you activate the JFR event.
This is JFR code.
Or not. And here you can see that there is a try yield here, and the try yield will call yield continuation, and yield continuation will call continuation.yield here, the one we have previously seen. So what a virtual thread is, it's a thread that will run the runnable or the callable inside a continuation, and instead of blocking, it will yield and copy the stack on the heap. And then when the data come back, in case of a sleep, when the timer let's say pop, it will schedule the continuation back by calling continuation.run inside. So this whole part is written in Java. The part which is not written in Java is the part that copy the stack. And the GC, because now the GC has to crawl the stack that are copied on the heap to not freeze the object that are on the stack here. Let's take another example. It's the same example as with thread.sleep, but instead of doing thread.sleep, here we call counter.get and increment here. And counter.get and increment is just a counter, and I have some synchronize block here and here. If I run this example, you see that this worker thread, the platform thread, is always the same. Let's run it several times. Okay, so there is a bug somewhere, because the virtual thread doesn't hop between platform thread. It's due to an optimization that, which is a nice optimization, but the way synchronize is implemented, synchronize store a pointer on the stack. It stores the address of the lock on the stack. So it cannot be copied. You cannot copy the stack, because now the stack has an address on the stack. So, which means that we have to re-implement synchronized. Currently, there are two different efforts to re-implement synchronize. One from Red Hat, which is still an implementation in assembly code, but that doesn't store a pointer on the stack. But it's slightly less efficient than the current synchronized implementation. The other effort is one by Oracle, and the idea is to implement the whole synchronize using only Java. It's not clear which one will be used or a combination of the two, but it's a limitation that we have currently. It's not a limitation that we will have forever. It's just a limitation due to the implementation of the synchronized block in the JVM, in a hotspot, exactly. By example, it's exactly the same code, but I have changed the counter to use a reentrant lock. I don't know if you know, but reentrant lock are lock written in Java, and they do not use an address on the stack. So if I run exactly the same code, you can see that here I have moved from the worker 1 to the worker 3. So if you don't want to wait until the synchronized block, the implementation of a synchronized block are rewritten, you can still use a reentrant lock instead. So basically, this is what have been done in the Postgres SQL driver. They have removed all the synchronize and use reentrant lock, so you can use it with Loom without any trouble currently. So just to be clear, don't take your code next week. Don't crawl all your code and replace all your reentrant, all your synchronized by reentrant lock. But currently, if you want to use Loom, one issue we have is that all your dependencies may use synchronize. So if it's in synchronize, which is not, you have it synchronized because you want to access to these resources. It's not an issue. The ones that are an issue are synchronized that do some call that are blocking inside the synchronize. Because this blocking call will not be able to copy the stack, even if you use a virtual thread. Yes, we have a question here. Do we have a mic?
If you shout it loud enough.
Yes, I can shout quite strongly, yes. Yeah, I wanted to know if I understand that we should go into our code and remove all synchronized block for this reason, but is there a good reason, except for this field.thread issue, is there any good reason to keep using synchronized instead of reentrant lock in some places, or we should always use reentrant lock for new code?
I think the answer,
I think we should repeat the question.
Absolutely.
So the question is, should we always use reentrant lock instead of synchronize? The main issue is memory. Reentrant lock use more memory than synchronize. But reentrant lock works better when you have contention, when you have a lot of threads that are waiting on one lock. So usually, if you don't have a lot of lock, using a reentrant lock is fine. But if you're starting to do something like I have 1 million of objects and each one have a lock, you should use synchronize in that case. Okay, any other questions? Yeah.
It's relevant to what you showed previously. Is the copy of the context when you switch from a virtual thread to another, or to a platform thread to another, isn't the copy of the entire stack isn't an issue?
So it's a very good question.
That you need to repeat.
Yes, that I need to repeat. Thank you. So the question is, you say that when a virtual thread is blocking, basically it copies a stack from the stack to the heap. But doing this copy back and forth between the stack and a heap can cost you a lot. And the answer is yes, but there are some optimization. So the first copy will do a full copy, but when you copy back, usually you don't copy the whole stack frames, but you try to copy only the topmost stack frame, because you know that usually you will stay on top of the thing. So there is a quite nice trick in the implementation to only copy the relevant stack frames if possible, and it's lazy, and it try to learn how many stack frame you should copy by default and things like this. So that's the nice the fact that in Java we have a VM, we can do this kind of trick by instead of copying everything back, we try to copy some part. Does it answer to your question? Yeah, thank you. So I think we can restart. We may switch
Need
now.
to switch back?
Yeah. So we have nice slides that explain how it works internally, instead of showing C++ code.
I put it there and switch this back. Okay, so that's basically the movement. So that's basically the movement that we just saw. You have this stack, which is the stack of the virtual thread plus the platform thread that is running this virtual thread. And when you call sleep, and this is the code that you just showed, Remi, then the portion of the stack associated to this virtual thread is just copied to the heap memory. And at some point, in the case of the sleep, the timer will notify the sleep method that it's done, that it should be awakened, and then this stack will be copied back to the platform thread. Now, because it happens in this fork join pool, it may be scheduled again on a thread, on the platform thread that is busy, and there may be another platform thread that is free to run something else. So this virtual thread, and this is what you just saw on the demo, this virtual thread will be in fact scheduled on another platform thread, will be executed by another platform thread.
Yeah, by default, by using the fork join pool, it will try to reuse the same platform thread. By reusing the same platform thread, you can reuse the cache and things like this. But if the platform thread is busy, it will switch to another thread.
Absolutely. So that's the code you just saw. I'm going to skip it. So basically, if you want to wrap this up, a platform thread is just a wrapper on an operating system thread, whatever the operating system you're using. And a virtual thread is just running on top of it. It needs a carrier thread to be executed. But because of this movement, this ability that virtual threads have to be copied in a heap memory when they are blocked or sleeping or whatever, then the idea we had previously that when you submitted a task to a platform thread, you cannot detach this task from this platform thread. Now you have this possibility. The task is still bound to its virtual thread, of course, but because the virtual thread can be unmounted from the carrier thread, everything is happening just as you could detach this task, this blocking task, from the platform thread. Okay? A virtual thread, in fact, only consumes CPU resources when it's doing something. If it's blocking, then it's just in the heap memory. It is not working. It's not using a carrier thread anymore. So the way things are working are really the following. You have a collection of platform threads installed on the cores of your CPU. They are not moving. They are there. And they will see a virtual thread coming back and forth from the heap memory when they are not blocking. If they are blocking, they are just not there. So with Loom, you do not need to block a platform thread anymore, which is very good for your performances, I would say.
Yeah, because you don't rely on the OS switching, and doing an OS context switch costs you a lot.
Exactly. So it means that with Loom and virtual thread, creating a virtual thread is cheap. It's about 1,000 times cheaper than creating a platform thread. It's not free.
Yeah,
nothing is ever free.
Also 1,000 times more expensive than creating one object.
Yeah.
It's right in the middle between creating a platform thread and creating an object.
But remember that we were looking for a factor of 1 million, so we already did 1,000, which is nice. That's half of the way.
Yeah.
On a logarithm scale.
Yeah, but it's not fully free like
no,
creating
it's not free.
An object.
It's written cheap. It's not written free, right? Blocking it, the price of blocking it is just the price of moving the stack back and forth when it's possible. If there is some addresses in this stack, then this virtual thread will be pinned on the platform thread. If this virtual thread is not blocking, or if it just goes through this synchronized block, if it's a synchronized block, very quickly, in the order of the nanoseconds, then you will not have any performance issue. Now, if you have some I/O in that with the blocking stuff, then this will also block the platform thread. But it's not that bad, because in fact it means that this platform thread will be unmounted from the core and replaced by another platform thread. There is a mechanism inside Loom that will create another platform thread, and this other platform thread will be installed on the CPU until the pinned virtual thread is done with its blocking operation. So it also means that pooling virtual threads in executor services, there's no point in doing that, because you don't have to pool a resource that is cheap. You pull resources when they are expensive, not when they are cheap. So pooling virtual threads in Loom is just useless. You do not need that.
Yeah, it's really an anti-pattern. If you try to do it, you will see that your code runs slower than not doing it.
So don't do it.
Don't do it.
Just don't do it. Another highlight I would like to say again is that Loom is not implemented. Well, it's partly implemented by the JVM. The JVM is basically doing two things. First is this copying of the stack back and forth with the heap memory, between the stack and the heap memory. And second, the garbage collectors have been partly rewritten to take into account the fact that you may have references in these portions of the stack that are in fact sitting in the main memory. So they need to check that, but just to work, in fact. And that's it. This is also one of the reasons why it took so long to
it doesn't take
Loom.
so long, actually. I
But
think
that's 4
Loom
years, 5 years.
Yeah, but
I think the first presentations about Loom here were like 5 or 6 years ago.
it was 2018, I will say. It's I mean,
That's 4 years.
given that we have but we have something called COVID in the middle, I think. But
Can't remember that. What you're talking about?
and you have what was the number of line changed?
100,000? It's
Yeah.
not that much. Come on. All right. So in the JDK, all the blocking codes, and we're mainly talking about Java NIO, has been rewritten to take into account the fact that the thread that is running this blocking code may be a virtual thread, and that is going to execute this code in a continuation so that it can be pushed on the stack to do that. So basically, if you're using Loom and doing Java NIO stuff, which can be either on the network or on your disk, well, you're good to go because this code is already ready. So we already talked about the fact that there are some virtual threads that may be pinned on that, so I'm going to go through this because we already talked about that. There are also things that have been rewritten. Sorry,
Just
you want to say
just
that?
to say, there are two main cases. One is the synchronized block. The other is when you have a C code, when you have a C stack frame in the middle of your stack. Because C code can do anything, it can store an address on the stack. So if you have C code in the middle, the virtual thread will be pinned exactly the same way. And currently, it's an issue for Netty, by example, because Netty use C code in the middle of the stack.
So yeah, so it's pinning the virtual threads. And so there are already several elements of the JDK that has been rewritten to remove the calls to C code that will prevent this virtual thread to be moved to the heap memory. And there's one I wanted to show you, which is the re-implementation of the method class from the Java reflection API with method handles. In fact, in the invoke method of the method class that is used absolutely all over the place by all the framework you can imagine, there was a C call in it which would have prevented this copying of the stack. So that's one of the reasons why it has been re-implemented using method handles as part of the JDK 18.
Yeah, because method handles are fully implemented in Java.
That's Java code. So there are already a lot of work that has been done to update the JDK to welcome Loom and to make it Loom friendly, virtual thread friendly, I would say. Great. So now with Loom, we can use as many threads as we need. 1 million threads is okay. It takes only 3 seconds to launch them on a Mac OS, which is just a laptop. I mean, it's not a high-end server, of course, which is nice. But it also raises an issue, right? When you're debugging your application, you know your IDE with the debugger perspective, for instance, on Eclipse. Currently, you have a little panel with all the threads that are listed on your JVM. If you have like 50 of them, 60 of them, it's okay. But what about if you have 1 million of them? Will this panel be able to display 1 million threads in it? I didn't try. I don't know if you tried.
I didn't try.
I didn't try neither. Maybe we should try that.
The panel is an issue, but the human brain trying to see the panel is another one.
Yes, and also the wheel of your mouse, because if you need to scroll down all this list to find in what thread the task you're trying to debug is running, then it can take you several years, actually, probably. Okay, and maybe your mouse, you will have to change your mouse, because before the end, your mouse will break down. So, in fact, the idea behind that is that having virtual thread and having so many virtual threads raises the issue, what are we going to do to handle so many threads? Okay, and remember that the pattern we used to have, starting with Java 5, is to interact with executor services and not with threads directly. Well, it turns out that with Loom, you're not supposed to interact directly with virtual threads neither. You can do that if you need that, of course, but you don't have to. The idea is to bring a new kind of APIs called the structured concurrency. And this is what we're going to see now. We have an object which is called structured task scope, which is I was about to say a pool of thread, but it's a pool of virtual thread, and there's no virtual thread in it. So it's a pool of thread with zero virtual
It doesn't
thread.
store the thing, so it's not a
And
pool.
it doesn't store anything. Just start a thread when you need it. And
It doesn't do the join in the wrong order too, so it's efficient.
it's super efficient. And this is, what about we take a break now, and we talk about structured concurrency after that?
Yeah.
What do you think? Is it okay for you? Do you need a break? Oh, yes, you do. Okay, so what about we take a coffee and we talk again in about 20 minutes? Is 20 minutes okay? All right, I hope the coffee was good. So let us carry on with this presentation. So the first question, and we already asked about it before the break, is that why do you need structured concurrency? The short answer is you need a tool to handle these several thousands, hundreds of thousands of threads, millions of threads that you may now have in your application with virtual threads. Launching a virtual thread is cheap enough, and blocking a virtual thread is cheap enough to really launch and block a virtual thread without even having to think about it. So let us go through that. The main object we're going to talk about is it's called the structured task scope. I'm going to call it a scope object because structured task scope, that's not a very speaker-friendly class name, I think. They should have thought about that. Okay, and we're going to go through an example which we call the travel agency example. Okay, this is a travel agency that sells travels, and because when you want to sell travel, you'd better explain that the person you want to sell travel to, that the weather is going to be nice in the place this person is going to. So along with the travel page, you have two information on this travel page. First is the price of the travel, the quotation, and second, an information that is nice to have. It's not critical, but it's just nice to have, which is a weather forecast. All right, and we want to create a system that is completely asynchronous to deal with that. Now we have many tools to do that, many asynchronous framework which will deal with that quite easily, and I would say quite efficiently. If you want to write the completable future pattern for this stuff, you will end up with this kind of code. Okay, you have two asynchronous tasks, quotation and weather. Then you can handle the exception with the exceptionally method of the completion stage API. And then when you have the quotation, you will compose it with the weather. And once again, you can handle exception and even timeout if you want to do that. And this is the kind of code you're going to write. I wouldn't say that it is super hard to write code. I mean, it's doable. It's not that simple, but it's okay. It's not super easy to read code neither. You probably need to concentrate a little on it to really understand what it does. All right. Writing a unit test for that, you can write a full test on it. A unit test, if you want to test really the different steps, it's going to be hard if possible. And in fact, if you consider this case, it's a simplified version of the use case you want to write, because this is not what you want to implement. The real use case you want to implement is this one. You want to query more than one quotation server and get the best price. So you have more asynchronous stuff there, and you have a business rule to extract the element that you will want to present to the user in the end. And the same for the weather forecast with a different rule. The weather forecast is supposed to be the same whatever server you are querying, hopefully. But what you want to get is the first server that is going to give you a response, and forget about the other one. All right. You can do that with the any of, completable future any of. But the semantic of the any of completable factory method of the completable future is not that great. It returns you the first task that is going to provide an answer, even if this answer is an exception. So you may have an exception for the first answer, not for the second one, but you will have an exception anyway. So you probably need to dig a little into that to do this kind of thing. So how can you write that with the structured task scope? I'm going to switch to the IDE. Now you cannot see anything. I know that. But if I do some little magic on this laptop, you should be able to see something. Okay, so this is basically the main method of my travel page. We are going to put it in a Spring Boot application in just a minute. But for the moment, we are going to stay there. For the moment, it's completely synchronous. This travel stuff is a record. Okay, this is Java 17 plus, so we're all using records now. Yeah? We all agree on that? Obviously, yes. And this travel is built on two components, a quotation and a weather, right? And we are going to deal with the weather first. I'm going to check this read weather stuff. Oh my God, what's happening? Okay, and this weather is also a record. This is Java 17 plus, so we all love record, don't we? Okay, and I have here some code that is kind of simulating the fact that I'm querying remote servers. Okay, I am sleeping for an amount of time. A chrono unit is a millisecond for the moment, and it will stay there, by the way. And I'm waiting for a random amount of time between 30 and 110 milliseconds. And different random time if I'm reading from a server B, and different also if I'm reading from server C. Okay, it's in the order of the tens of milliseconds, so that's almost the amount of time it takes to query a REST server somewhere on the web. This is why I chose that. Okay, and for the moment, this read weather is just reading from A, so it's fully synchronous, no multiple thread whatsoever. And I'm going to go back there, and I'm going to just run this code, and hopefully it's going to work. So I have both activated the preview feature to be able to run on virtual threads, and also the incubator module, JDK incubator concurrent, because this is where the structured concurrency API sits. Okay, so I have my travel page, which is this stuff. Not super exciting, but this is what I have. So how can you play with this structured concurrency stuff? Well, the first object you need is this scope object. And I'm going to create it in that way, new structured task scope. It needs a parameter, which is in fact the parameter of the callables that we are going to submit to this object. So you could see this object as an executor service. It's not an executor service. It works in a very different way, but it's basically something that we are going to use to submit callables to it, and that we are going to join to get a result. So this is what I'm going to do. And by the way, this is an auto-closable object, so I'm going to surround it with a try-resource block, okay, just in that way. So it means that this structured task scope object is created within this method and dumped when I leave this method. And along with it, all the virtual threads that are going to be created will also be dumped when we exit this method. Okay, so that's very different from an executor service. An executor service, you create it when you launch your application, and you shut it down along with your application. Okay, it has the same life cycle as the one of your application. A scope object, structured task scope, has a life cycle that is very short and that is bound to the asynchronous computation you want to do with it. So I'm going to submit tasks, and for that I have a nifty method called the fork method. Okay, and because this is Java 8 plus, I like method reference, so I'm going to write it in that way. Okay, that's a callable, basically. And I just submitted this callable to the scope object. So now a virtual thread is going to be created and is going to execute this callable for me in this virtual thread. And I'm going to do the same for B and C. Okay, and to make sure that everything has been done, I'm going to call scope.join. Okay, join will return once all the callables I submitted to my scope object are done, are complete, either normally or exceptionally. Okay, now this fork object, this fork method, returns a future object. So I'm going to put all this, by the way, I can put it in a var, what I'm doing. Okay, because today I like var. I know you like vars, Remi, yes. You saw? I'm using var. This is going to be A, B, and C. Okay? I'm going to get rid of this. Okay. So now I can get these future objects, analyze the content, either the result or the exception, do something with it, and then produce a result. But what I want to do with this weather querying is, in fact, get the first server that is going to provide the response and forget about the other one. All right. So if I do that, I'm basically waiting for the slowest server to provide the response and get all the results should be the same. So I just need to pick one and to return that. So I'm going to use another object instead of the structured task scope, which is called the shutdown on success. Now, what is this structured task scope going to do? It's also a structured task scope. It's an extension of the first class structured task scope. All right. But the shutdown on success will do exactly what I need. That is, shut down the scope and interrupt all the virtual threads that are still running in it once a first task produced a result. It's not the same semantic at the any-off. The any-off will stop when the first task is done, either normally or exceptionally. The shutdown on success scope will stop when a result is produced. That is, if the first task is producing an exception, it will wait for the next one. Okay, and of course, if no task produces something, it will throw the exception. Okay, so what I could do after the join is first return scope.result, because there is a result method on the scope object that throws an exception, so let me catch it. I'm not really interested in this exception. And by the way, it should not be thrown, so that's fine. Okay, so there's a result method on this side because I don't know which of these future is going to produce the result. But what I can do before returning is, is print the state of all the futures. Future B, future C, and print the state of these futures, because I have a state method on the future object that will tell me if this future is still running, if it has been cancelled, if it's in success, etc. I think that's a new method added along with Loom. We didn't have it before. So now I can run my code again. Okay, and you can see, oh, I have two in success. So the agency that won was the A agency, and you can see that the C future is failed, and the two others are in success. Probably because Loom, well, the scope object was not fast enough to cancel it. So let me just run again. Of course, now the three are in success, which never happens, really. You have to do a presentation too if you want to see that happen. So that's the normal case, all right? Two are failing and the other are, and the last one is successful. Okay, that's nice.
Yeah, so they are failing because they are interrupted. Yeah. Because the first one succeeded, so the other are interrupted.
So actually, I don't need these. I'm going to get rid of it. And I'm going to get rid of it because it was just to show you how it's working. I don't need this neither. So now I have something that is fully asynchronous. Every callable is running in its own thread. All right, and I get the result from the scope.result in that way. And you can see that the code that I just wrote is itself fully synchronous. All these elements are running in the same thread, which is the thread running the read weather method. So it's super easy to check. Reading it, I think it's quite easy. If I need to add one more task, I just need to duplicate this line and add one more method. Easy to read, easy to write, easy to unit test, and fully asynchronous. So that's a very different pattern than the one we had with the completable future API.
Or any reactive API.
Or any reactive API. All right. So that was the main method, okay, running this stuff. Now what I can do is also running as part of this Spring App stuff, which is a Spring Boot application. It's a version, you said me, so it's version 3 of Spring Boot, is it?
Yeah, it's the upcoming Spring Boot application. So it's Spring 6 and Spring Boot 3 that will be released depending on how you who you are asking in between November and the first month of next year.
So that should be January.
The first month.
Oh, one of the first month. Okay.
Yes.
Usually the year begins with January.
Usually.
But you know these days. Okay. So and this is the Spring App class that I guess everybody knows. And you can see that in fact you can set up the executor service you want for Spring Boot, so that it's going to use the virtual threads from this application, from the executor you're providing. Sorry. So here we're using an executor, which is the new virtual thread per task executor. And as you can guess, this executor is in fact just an implementation of the executor service interface that is going to create one virtual thread every time a task is submitted to this executor.
And the tasks are not stored in any...
within the executor service.
Yes.
By the way, if you want to check your application, if you have a concurrent application and you want to check it, if you want to see if it's going to run on virtual threads and if you have any performance gain, you can use, and you're built on top of an executor service, you can just refactor the one line in your application where you're creating this executor service with this line of code, okay, and your application will be running on virtual threads. So that should be super easy to do. All right, so, and I'm going to run this application.
So yeah, we need to do it twice because
yes,
you have two APIs on Spring. You have the MVC API and the WebFlux API.
So yeah, that's right. So I'm going to run this. Hopefully it's already configured, so I shouldn't have any issues. Oh, look, it just ran. Okay, and now if I switch on this, the thing I want to show you is that, want to stress out, is that we are built on top of records. Weather is a record, travel is a record, and quotation is a record. All these are record. And if I check this Swagger UI, you can see that, on which one did I put it was on quotation, right? You have all these records that have been taken into account in a schema that you have there.
You can already use the current Spring Boot with records.
Yeah.
It's not something in the incoming new version. You can already use record for input parameter or output parameters.
And here I have, for instance, the request body with a quadruple I. I'm going to get rid of. Was it here? Where was it?
No, it's in services. It's an input parameter.
Oh, yes.
Yeah.
Sorry. Okay. Oh, no, I shouldn't do that because I should refactor it. Okay, and I think I need to if I would just refresh that, yes, I need to relaunch because it's a parameter. So let me do that.
No, it's because the API we use generates the thing once.
And that has been fixed. All right. So I have a first. So let me get rid of this. I have a first element here, which is the current thread that is going just to print the current thread that my HTTP request is executed in. So if I do a request on this one, you can see that it's actually running on top of virtual thread. And if I refresh it, you see that the number of this virtual thread is increasing because the virtual thread is just created on demand and then just destroyed because we don't need it anymore. Okay, so let me go to this travel page. So that's an HTML page, and if I want to go to...
it's a nice application.
Yes, I love it. You designed it, right?
Yes.
No travel found, retry later. What does it mean? Sorry. I have an exception. No class death found error. That's an exception. I love this one. Okay, so I thought it was okay, but it's not. So I'm going to. Where did I put the stuff? I think I put it here. Yes. I need to export that. I need to export this
you
guy.
can run with Maven. It will work.
Yes, but
No, you don't like to run with Maven. Okay. It's modified, yeah.
Apply, okay, run again. Refresh. Antwerp. Because today I want to go to Antwerp. Well, we are already in Antwerp technically, so we don't really need to go there. Okay, so nice working. And we have the sunny weather that is displayed by the weather agency C, and you can see that it can change to the B, etc. So that's the weather agency we just created. So we're going to concentrate on the quotation server, because of course, the quotation server is built on the same model as the weather forecast server. Okay, so it will wait for a certain amount of time with the thread.sleep. Right, and then it will return a price that is also random. So we don't know in advance which of this stuff is going to answer. And I'm going to use the exact same pattern as previously. That is var scope equal new structured task scope. The nice thing is that this pattern is always the same. So you cannot, it's super easy to reproduce. I'm going to put that in a try with resource, and then I'm going to fork that quotation read from A, read from B, read from C, all right, and called scope.join. You should always call scope.join. If you don't, you will have exception when you try to analyze your futures. And now what I could do is just do the same, that is get the futures from here, all right? Get the results from this future, get rid of the exception if there are exceptions, and get the lowest price of that. And writing this code will be just straightforward. But what I would like to do is do something a little more interesting, that is instead of doing that and mixing technical and business code in this try with resources statement, what I would like to do is just return scope.bestQuotation. Okay? Of course, this method does not exist, and there is no way I can add it to this class because it's a class from the JDK. But the classical way of adding behavior to a class when you cannot modify it, of course, it's to extend it. So I'm going to extend this class with the quotation scope. Okay, and I'm going to extend you structured quotation, and now this is a quotation scope, and now I can add this method freely because that's my class, so that's fine, and I can return null, and everything is okay. All right, and you see that the pattern I have, I don't need this guy anymore. The pattern I have in my read quotation method is the exact same pattern as the one I had in my read weather, and whatever you do, this pattern will always be the same. Okay, you fork, you join, and you get your result. And if you cannot get the result with the scope provided by the JDK, extending a scope and creating your own is super easy. We're going to do that. And this is probably the best method you can follow to use this pattern. All right. Yes, let us move on. So there's one method that is doing the magic that you need to override in this scope object, which is the handle complete method. The handle complete method takes a future as a parameter, and you need to handle this future. By the way,
there is something which is this method is called by each virtual thread. So
yeah.
You have to deal with concurrency here.
We're going to do that. The super method doesn't do anything. Okay, so you are just putting your code there. The future you are getting there is a complete future. Either there's a result in this future or an exception. Okay, but you shouldn't have a running future when you get that. The right pattern to use this is to switch on the state of this future, future.state, and handle all the cases you may have. This state is in fact, an enumeration with 4 cases running, and you shouldn't be called with a running future. That's a bug. You need to report it on the Loom mailing list if you come across this. Failed, it means that this future has an exception. It's carrying an exception. Success, that's a happy path. You have a result in it. And cancelled, this future has been cancelled. The virtual thread has been interrupted by the scope itself. So let me start first handle the running case. So here I'm going to throw an exception. New illegal state exception, that's the one. Oops. That shouldn't be happening. The happy path is the success path. And in that case, I'm going to store the quotation in a collection, future.result now. Result now is also a method that has been added as part of Loom on the future interface. It is going to fail if you call it on a future that is not done. The case failed, I'm going to, so now my future has an exception. So I'm going to do the same, store this exception in also a collection, and in a cancel case, I'm not going to do anything because I don't know what to do in that case. Actually,
there is nothing to.
There's nothing to do. Okay. So now that's a collection. Collection. That's a collection of quotation. Okay, and the other one is a collection. So that's exception. Exception is a collection of ThreadLocal. Okay, because exception now returns a ThreadLocal. So that's why. Can you show that to me? Yes, that's a ThreadLocal, so you need to have a collection of ThreadLocal. Okay? And now you need to think twice.
You need to initialize them.
Yeah, absolutely.
You need to add final.
Absolutely. You need to think twice about that because you need to understand all the race conditions you may have there. Remember that virtual threads are working in the exact same way as classical platform threads. So all the things you love, race conditions, blocking, etc., are going to happen in the exact same way. So you need to be aware of that. Okay, and there are 2 things you need to understand. So first, as you mentioned, this handle complete method is executed in the virtual thread that executed this future object, that produced this future, that filled this future object. So if you check that, we submitted 3 tasks. Each of these tasks is going to be executed in its own virtual thread. So this handle complete method will be executed in 3 different virtual threads. So these 2 collections need to be concurrent collections. If they are not, you will have a race condition in these collections. So don't put a array list here, it's not going to work. Well, it may be working, but not all the time, which is the nice thing about race conditions, right? It's always working on your machine. Concurrent link deck, link queue, do you like it?
Why not?
You don't mind? I don't mind either. So I'm going to put it here, right? But you have another bug, you have another race condition. Because this quotations reference is read from all the virtual threads this scope object is creating, that is 3 different virtual threads, okay, and created as part of the creation of the quotation object, which is created in yet another thread. So you have in fact 4 threads here, okay? So these 2 references are created in a thread and as references read from other threads. So that's another race condition, okay?
But it only appears on ARM. not Intel. So it's really great. You will not discover it until you run on ARM.
That's yeah. This is what is nice with the race condition. It's an endless source of surprises. Yes, question?
Yeah, I haven't really understood why there is a race condition because as far as I can see and understand, the constructor, the initializer should run before we enter
No.
the try state.
So the question is about the race condition. I repeat the question.
Yeah, sorry.
The question is about the race condition on the reading of these references, because when you get the object is fully initialized. Yes, but in another thread. It's not a matter of scheduling, it's also a matter of visibility. So you need to make these changes visible from other threads.
So basically what the Java spec says, it says that another thread can see the field of an object not initialized after the constructor by default. You need to add final to force the initialization inside the constructor. And the VM will put a barrier only if it's an ARM.
That was tricky.
Yes.
That was tricky. Yes, it was. But now you know it, so it's okay. But I mean, putting final there makes sense, whatever you do. So yeah, it makes sense, and it's a good idea. All right. So now I have this stuff that is done, and now I can do something for my base quotation method. And this base quotation method is in fact quite easy to do because what I need is the base quotation from this method. Okay. Yeah. Question.
Sorry, just to further understand of the former problem. I wouldn't do this, but if I replace final with volatile, it will work the same, right?
So the question is, if we replace final with volatile, it will also work, and the answer is yes. You don't really need volatile here because final is okay. But if you have a mutable field here, which can happen, here it's not the case because it's a mutable object. You mutate the content of the object and not the reference itself. Then final is okay, but volatile would work also. You agree?
Yeah. You just pay the price each time you call
Yeah.
handle complete, because when you have a final a volatile read, every optimization you have done above everything you have stored in register will be lost.
I was not suggesting it, just
Yeah.
trying to understand the problem.
Yeah.
Okay. So now this base quotation is just very basic stream API code, Java 8 code from, this quotation, code from 8 years ago, 9 years ago almost. So I'm going to stream it and then to take the mean, comparator, not correction, comparator, comparing quotation, column quotation, and then I get an optional, and I need to call this or else throw method. You shouldn't be calling the get method on optional anymore, because it's a getter that throws an exception, so it's kind of a weird thing. So that's the preferred pattern now. Okay, and if this is purely business code, it's a very simple business rule, all right. But it's a business rule that you can unit test very easily. I mean, this method is completely isolated, so if you want to unit test it, it will be easy. It's not quite done. Yeah, you have a.
Yeah. No.
Okay.
It's okay.
Thank you.
You're comparing quotation.
I'm comparing quotations, yes. So
And quotation is comparable?
I don't think it is. It could be. We could make it comparable, really. You want to make it comparable?
What are you comparing here?
The quotation field, which is an int.
Oh, it's an int, so it's comparing int.
Oh, you want to put comparing int?
Yeah,
of course.
because
that's fine.
Otherwise you are creating integers.
You're right.
It's not a big deal. You have only 3, but
Yes, I'm saving 20 nanoseconds there.
something like this.
But I agree, comparing int is the best. But then I need to think about this problem, because or else a throw will throw an exception if the optional is empty, and the optional is empty in that case if quotations there is empty. Now, is it possible for quotation is empty? Well, I have an add method there, but this add method is in a switch. Okay, so it could happen that this add method is never called. If it's never called, it's probably because this add method has been called instead of the quotations.add. So I have people waiting in this exceptions collection, and I need to deal with them. So let me create another method, because I would like to do something with this exception. I'm going to show you how you can handle these exceptions properly. And I'm going to create my own quotation exception class, because I feel like doing that. Why not? We have the time. Private, come on. Private, static, class. You know what? I'm going to make it public, because we may need it in the future. Extends runtime exception.
Yeah.
I know you prefer runtime exceptions. I'm doing that for you, Remi.
Yeah.
Okay. Sure. Not what I wanted to do. Okay. Quotation exception, and I'm going to call it exceptions. Okay. And I'm going to use a mechanism from Java 7 called the suppressed exceptions mechanism. Maybe some of you are aware of it. I'm going to create a quotation exception. Okay. And I'm going to add, so new quotation exception, and I'm going to add all the exceptions from this collection here to this quotation exception as suppressed exceptions. So I'm going to do this kind of thing. I'm going to loop over the exceptions in this collection, and for each of these exceptions, I'm going to add it to my quotation exception. Add suppressed E, just like that. Okay, and I'm going to return this quotation exception. So if I throw this quotation exception, the stack trace, or if I inspect the stack trace, I will have the stack trace of the quotation exception itself, and then all the stack traces and error messages of all the exceptions that have been added to it as suppressed exceptions. This is how suppressed exceptions are working. And by the way, this is a nice method reference. And today I like method references, so I'm going to write it in that way, which is going to be even better.
Yeah. Just a quick fix. Can
Sure.
you add a final on your random object above?
Here,
Yeah, think.
you don't want to make it volatile. Final is okay. Okay, and now that I have this exception method, I can pass a supplier here telling, okay, if the, and by the way, this is another method reference, okay, so telling that if you need to throw this exception because the optional is empty, instead of running a dump empty optional exception, you will grab all the exceptions that are bound to be in the exceptions collection, and this is what you're going to throw. Okay? And by the way, I could, if I want to kind of do some logging or whatever, I could also call this exceptions method from here to do that. Because even if I can produce a result, it may be interesting to get these exceptions. All right? So we've written quite some code. And you see, I just want to stress this again. All the code that I've been writing is purely synchronous code. All these methods are executed in the same thread. I do not have any callback. The exceptions are properly handled. Okay, and I can unit test all these methods one by one very easily. So
you have an error.
Sorry? There's an error? Where is it? Oh, it's probably because, yes, it imported this Unicode set there. Let me get rid of this, because I don't need it. And so now if I refresh this nice page, and I want to go to Bonitable, for instance, because I like Bonitable, okay, right, it's sunny, and the price will be 99 euros, which is quite cheap, in fact. Oh, I should have taken the first offer. I'll never get a cheaper offer now. I'm doomed. All right. So this is how it works. We can do better with this code because here I don't know if you recognize that, but that's the new pattern called the switch. It's not a switch expression there. It's a switch statement. We agree on that. So it's a switch statement with this little arrow stuff that you can use. And because it's on an enumeration, you do not need any default clause, any default branch in this
Yeah,
in this switch.
And writing a default is actually an error.
Yeah.
Because if you write a default and you add a new enum value, you will not have the compiler saying one case is missing.
Absolutely. But we can do better than that. You know what? I'm going to create an interface, because today I like interfaces. Private interface, quotation, complete future. Okay. I'm going to make it sealed. All right. And I'm going to create 3 records. A first record that is going to be a success. And my success is built on a quotation. Okay, creating a record is really something that is almost free. That's a record. So if you don't like record, well, you should change your mind, I think, because it's really great. I'm going to create a failed record on a Threadable. Let me call it exception. Okay.
You have to implement.
Yes, I need to implement that. And then a cancel record that is not built on anything. Okay. And I'm going to say that all these records are implementing my quotation complete future interface. So this sealed interfaces mechanism is also something that is available in the JDK 17. All right. It means that this interface, in that case, because the records are declared in the same file, I do not need to add this permit clause, but I'm going to put it there anyway, because it makes things explicit. So failed and cancel. In a nutshell, the seal type, it could be any type, not necessarily an interface, but in that case, this seal interface can only have 3 implementations: success, failed, and cancelled. And if I try to add one, I will have a compiler error. And if you try to sneak another one in using some kind of bytecode manipulation at runtime, the JVM will catch you. You will not be able to do that neither. All right, so it's a very nice stuff. And now what I can do is create an off method there. I'm going to make it static. Off method, and I'm going to take a future to take this as an argument. Okay. And this switch there, I'm just going to copy it, paste it there. Okay. In the case it is running, I don't want to create anything because it's a running future and I shouldn't be observing this case. Here, I'm going to return that. So now it's not a switch statement anymore. It's a switch expression. I can also do that with the new switch, starting with the JDK 17. Okay. Now I'm going to return a success record using the future result now. And here I'm going to return a new failed record with the exception now, and here a new cancelled record. Okay. So that's basically the same switch as the one I have. And why did I do that? Because now what I can say is, okay, I'm going to use this interface, quotation. I called it complete future instead of complete future. Let me refactor that. Complete future. Yeah, that's the one. So complete future. Complete future. Yes, complete future equals complete future of future. And now I can refactor this switch because I can switch directly on the type. That's also a preview feature. That's the third preview feature in the JDK 19. And in the case I have a success on quotation. Sorry, I'm going to get rid of this because I don't have this case anymore. Success on quotation, I'm just going to add the quotation. Okay. The failed with the exception, I'm going to copy this one, paste it there, and just add the exception to the list. and in the case it's cancelled, well, I'm not going to do much, so I'm just going to do this. Okay, so now this switch is a switch on type, on the type of complete future. All right, and it's using another mechanism that is also a preview feature of the JDK 19, which is pattern matching on which is called record pattern matching. You can use pattern matching for the case labels of your switch. So that's the case label. You can use a pattern there, and here I'm using a record pattern. So I can directly deconstruct the success record and use this argument. Well, it's called the binding variable. It's the binding variable of the pattern, and I can use this binding variable as a variable and add it directly to the quotations stuff.
Yeah.
So now I do not have this useless case anymore. That shouldn't happen. It's hidden in the creation of the stuff.
Perhaps in the future version of this API, these will be integrated directly into the JDK.
That would be nice.
Because it's a nicer API.
Do you prefer this code or this one or the previous one? Who prefers this case with the enumeration? Can you raise your hand? A few hands. And this one? Well, I think that we have the answer. Thank you. Yeah, this is really nice. I have a warning here telling me that the switch label is only reachable in the whole switch. I'm not even sure what it means really.
It's just an IntelliJ bug.
And if I say, okay, can you fix this warning? Okay, don't do that. It's still a preview feature. So okay, the IDEs need to synchronize with this kind of preview feature. Great. So now I have, yes, I really love this pattern. Really, that's for me. That's just awesome to have this kind of thing. And pattern matching is only the beginning. I mean, we have one step at a time that is added to the JDK as preview features. When everything is there, writing Java code will be probably very different than what it is now, thanks to this kind of patterns of code. Great. So this is the. I'm going to get rid of this. Okay. So this is a quotation scope class, and you can see that it's not a very complex class. In fact, the most complex method you have to write is this handle complete method. You have basically 3 cases to handle: success, failed, cancel, probably not. So that's probably only 2 cases to really fully handle. And all the rest is just business code. It's as complex as a business you want to implement. If you don't want to handle exceptions at all, that you don't need this method exceptions. And if you have a very complex business rule, then your best quotation equivalent method will be complex. Okay. But you can do really any kind of thing you want. If, for instance, you want to add some kind of timeout, you can also do that. It's super easy to do. It's super easy to do. There is the join method. There is also, along with the join method, a join until method that takes a timeout. So after this timeout, all the virtual threads that are still running will be interrupted automatically by the process. Okay. Great. Where were we? So now if we query this stuff, find a travel. Well, yes, it's still working. We already did that. Now we have something that is both asynchronous for the computation of the travel price, which is this guy and the agency there, and for the handling of the weather forecast. We have these two things are asynchronous. Now what we need to take a look at is the travel page main. Sorry, is the read travel stuff, because this travel stuff is not asynchronous. This is synchronous. It's executed in a virtual thread of this request, the HTTP request we're doing, and the read quotation and the read weather are launching scopes internally, but this should also be written in a scope. Okay, so let me do that. And by the way, because it's so much the same as previous one, I'm going to be lazy. Where's my quotation record? I'm not going to copy it because I will need to change it. So I'm going to create a third scope. You see that creating scope is not complex. Creating a scope is so easy. Not there. Travel page scope. Okay, and that's going to be a class, public. Let me make it private. Private static. Class. Come on. Travel page scope that is going to extend structured task scope. What am I going to put here? The type I need to put here is a type that should be common to all the elements I'm going to submit, to all the callables I'm going to submit to this scope. All right? And so far I only add quotations or only had weather. Now I have both a weather and a quotation. So I could put an object there, because as of now it's the only common elements, common type of these two things. Okay, I'm going to put that in a try with resources statement, and there I need to fork this stuff. By the way, that's a callable. Okay, and read weather. And I'm going to follow the same pattern, that is return, scope.join. All right, and return scope.travelPage, because putting my business code in a specific method will help me testing things in an easy way. And now I can get rid of this. I'm going to add this return null, which is fine, and these are method references. So let me write them as method references. Having object there, when I'm going to write this handle method there, where is it? You're here. Okay, I will have a future of object here. And by the way, I'm going to, where is my quotation? It's here. I'm going to copy this because this code is going to be exactly the same. Okay, so I'm going to copy you here. This shows that it should really be in the API because it's the exact same code. I'm just going to call it travel page complete future. Travel page complete future, and that's it. All the rest is exactly the same. So I don't need anything more. So now I can have a travel page complete future of future. Oops. No. var complete future. Can I put you like that? And I'm going to switch on this complete future. Okay, and now think a little about it. And this is what, by the way, this is what I'm going to return. Okay, and I'm going to copy this again because it's going to be the same. Up, Control C. Okay, so now what I have here, the problem is what I. Oh yes, it's not quotation anymore there.
Yeah, you have the problem here.
Result now. This is an object. This is an object. Yes. No, I'm not going to copy this. I'm going to keep the cancel case because this one is fine, but the others are not. Okay. The problem with success here is that if I have a future of object, then in success I can only have an object. I cannot have anything else. And what I know that I have is only a quotation and a future. So creating a common type for these two, quotation and weather, really makes sense there. And we just saw that we could do that with the seal types. If you check seal types give you the possibility here. not to have a default clause there, because the compiler knows that the success, failed, and cancels are the only 3 implementations allowed for the quotation complete future. You do not need a default clause there. So I could have the same stuff for quotation and weather on the other type. So I'm going to call it, I don't know, page component. Do you think it's okay, Remi? Page component. Do you like it?
No.
So page component that Remi doesn't like, is it okay?
Naming is hard.
Naming is hard.
Per programming is hard. Yeah.
Okay, per programming, oh, come on. I'm going to create this interface there. New interface, well, okay, class, interface, page component. No, page component just. Okay, great. And I'm going to, oh yes, please add it to Git. I so need that. And it's only going to be allowed for quotation and weather. Okay, this time I need it. It's a sealed interface, sorry. This time I need it because quotation and weather are declared in a different file. So, and quotation will be.
I think you can fix it.
Sorry?
I think your IDE can fix it directly here. Yeah.
Oh, you're right. Great. And now I need to go back to the travel page. Okay, so now it's page component. Why did I? Yeah. Come on, it should work.
No, because the structure task is already.
So now this is page component, and now this is page component. No, it's not working neither. Because I fumbled in the name of it. It's page Come on. I didn't put it in the right place. I didn't put it in the right place, I'm sure. Yes, it's in travel page. It should be. It should be there. Oh yes, add to Git, please. Quotation weather. Implement. So now it's working. So result, so that's fine. Success is there, so that's a success of page component. And that should fix it. Okay, and that is not working because I still need to have some more cases out there, which is fine.
You can name it page component instead of quotation.
Here?
Yeah.
Component? I can name it in
yeah, yeah, it's pair programming.
Okay, that's fine. No, you're right. It should really be component. Okay, so that's the complete future. All right. So now I have the case success.
No, it does. Yeah.
Yes, no, it's completely lost. So I cannot. Okay, I'm going to copy this, and now that's a page component. So I need to switch again. Well, yeah, I don't necessarily need that, but I could switch again on a component. And because it's a seal type, I have only 2 cases, which is quotation. Okay, another pattern matching, but this time it's only a type pattern matching. So I do not need to deconstruct the quotation object. But I'm going to say that this quotation is equal to quotation. Okay? And here is the weather. This weather equals weather. All right? And I do not need a default clause because it is a switch on the seal type. So, yeah. No need for default clause. And now what I need here is these 2 fields, and because these fields this time are mutable, I cannot put them final. No, that will not work very well. So I need to put them volatile. Okay. Why aren't you happy? Because it doesn't cover all the possible values, because I also have, sorry, a case failed with a throwable in it. Exception. And by the way, I have a quotation exception, then all my system is failing. I will not be able to show any kind of quotation to the people. So maybe I could have another switch there. Switch on exception. Okay, and if I have a quotation exception, yeah, it's really lost. Quotation exception, which is the class of exception I chose for the specific quotation type. What I'm going to do? Oh, you don't like it. You don't like it. And, it's in quotation, right? Maybe I should write it in that way. No, you don't like it neither. Is it public?
It's not in quotation.
Where am I?
It's in the scope. It's in the scope. And your scope is...
No, it's not.
It's not in
The scope is not there.
Yeah, but quotation exception.
I'm not in the right... I'm not... What am I doing? Oh my god. I've been typing this code in the wrong class. You know what? So I'm going to take all this. Take all this. Yes, I am in the right stuff. No, it should be in there. Why do I have two?
That's a good question.
It should be there. Oh, God. That's going to be a mess. I'm going to copy everything there. It almost worked. Yes, and now I have a quotation exception. Okay, great, perfect. So what I'm going to do there, problem is that if I throw the exception there, I'm going to break the thread, the virtual thread that is running this future, and I don't want to do that because it will not be reported whatsoever. I'm going to break a thread. Well, I'm throwing an exception in a thread that is going to die anyway right after this this method is called. So I need to store this exception somewhere. Quotation exception. Come on. Like this, and that's a switch statement, so that's okay. And if it's not the case, then of course I'm dealing with exceptions, so I have many types of exceptions that are possible. So probably I need another field, other exception, that is equal to exception, because it could really be anything else. So I'm going to create this field, create this one, okay, and make them volatile because this is what I need. Great. And this switch is not happy. Why aren't you happy, switch? Target type for switch cannot be void. What do you mean?
It's because you are in handle complete, which return void. You have a return.
Oh, you're right. So it's a switch expression, but that returns void. It's still a switch expression.
Switch statement, yes.
No, it's a statement, by the way. I can get rid of it. So it's a statement. It's really a statement. So that may look a little complex, but that's, in fact, is, as I told you, as complex as the business I want to implement is. I have basically two cases, getting a quotation or getting a weather. And everything can throw exceptions, so I also need to throw these exceptions. We could probably incorporate that in a response record, by the way, to get rid of this switch within a case, which is not very nice. All right, and now when building this travel page, I need to analyze all this. Okay, so if I have a quotation, maybe what I could do is say, okay, if the weather is not there, I could say weather, or maybe new weather. The first one is an agency, and this agency is unknown, of course, because it's not an answer. And because I don't want to get rid of my customer, I will say mostly sunny. Yeah, mostly probably sunny. I guess that's okay. That could even be a constant. Can I put it as a constant? Yes, in travel. That would be nice. And that is going to be default weather. Default. Nice. Nice weather. Okay. And maybe I could move you. Can I move you to weather? It doesn't want to be moved. Okay. I'll have to do it by hand. Where's my weather stuff? Oh, of course I have two weathers. That's great. That's going to be a mess. Okay, let me put it here. Okay, so that's working. So the weather cannot be null, but if the quotation is null, then I'm probably in trouble. I probably have some kind of exception in this quotation exception there, because that's why the quotation is null. So report this exception in some way. Okay, maybe a suppress exception of something else. And if the quotation is null, return new travel quotation, new quotation, unknown, with a very high price, just to make sure that the people don't want to go there. And weather, default night weather. Okay, but that could be weather, by the way, because that's already the default value of weather.
You can also throw the exception.
You want me to throw the exceptions?
Yeah.
Yes, but it's not going to be reported on the page.
It will.
You need to report something on the page.
I know the guy that have implemented the front-end part.
Okay. Oh, great. You mean you are this guy, are you? Throw this dot quotation exception. Okay, but it's not going to happen anyway. And if it's not the case, then I can just return a new travel with this quotation and this weather. Great. And do something with the exception, like reporting them, etc. So once again, this travel page method can be unit tested separately. It's as complex as your business is, and here it's a pretty simple business. Okay. This handle complete method is, I would say, the most complex method you need to implement. But once again, you are just dealing with one feature at a time, so it's not, in fact, impossible to write. Okay, and so now if I, sorry, this is not what I want to do. And now if I'm going to go there, and suppose I want to go to Brussels. Okay, Brussels, mostly sunny, WB. You can see that everything is now fully concurrent. Everything is fully asynchronous. Even the dealing with this read travel page is forking two different scopes within the read quotation and the read weather stuff. What we could do is add a little timeout there, because maybe I don't really want to wait for too long to have the weather. I don't want the weather to block the displaying of my travel page. So to do that, you can just call the join until stuff. This join until takes an instant, and I can call instant.now. Okay, and add, I got a plus millisecond, so if I want the result, for instance, in 100 milliseconds, and then I will have a timeout exception that I could also handle specifically within my application. If you're not happy with throwing a runtime exception or do some kind of fallback on some kind of default behavior, then you can catch it explicitly. You could also, this shutdown on success class is final itself. Okay, it's there, and it's a final class, so you cannot extend it, but you can still compose it if you want. So if you want to extend it, without extending it, you can just create your own weather scope object that is going to wrap this stuff and intercept all the calls that you need. That is you have only 3 or 4 methods to intercept, which is not such a big deal. And that will allow you to handle this join until internally, and instead of throwing an exception there, having a default result directly returned in the result method that you have here. Okay, so I'm going to put a little pressure on this guy because the min is 10. So if I put 10 actually, and refresh this page, I would like to see mostly sunny, but I don't. Rebooting the Spring Boot application, I can do that, but I don't think I should need to do that. I haven't done it. I only did it for the. That's done. I only did it when we changed the API exposed, the REST service exposed. So if I refresh you and type Paris, because at some point I will have to go to Paris. Oh yes, now it's mostly sunny. Okay, so you see that now we have handled the default value for this stuff. By the way, there's also something you can do with this API. I'm going to show it to you on the quotation object. You see, here you have this join method. Joining a scope doesn't mean that you cannot use it anymore. So you can fork a certain number of tasks, join the scope. The join method will return as soon as all your tasks are complete. And if you want to fork more tasks, because this is what your business asks you to do, you can fork more tasks and call join again. So you can fork, join, fork, join, as much as you want, as long as your scope is alive. Okay. I don't know if it was clear what I just said. Yeah. Okay. All right. So that's the gist of the structured concurrency part. It's still an incubator API, so if you want to play with it, by all means do that. And if you see missing features, then you can do that also. Maybe some people have questions at this point.
I will just add that it's not the first version. In the first version, the value were pushed in a queue, avoiding dealing with concurrency. Because if you push in a queue, it can be read only by the thread that fork the whole thing. But the problem is that you pay a lot of costs by doing this.
All right, so I'm going to try to go back to the slides. And you don't want to see that. So I'm going to do it in that way. Okay, great. So in a nutshell, the basic pattern that you saw is a super simple and super easy pattern to use. You fork tasks in the form of callables, and then you join. You have the guarantee that all your tasks are done, and you get the result. And because you can override very easily, extend the class, and create your own business method in that, you can really write your business code that is going to analyze the futures of these tasks, not in your business code, not in the code that is going to fork the task, but hidden in this handle complete method. This object really looks like the executor service object. The biggest, there are many differences because it's not the same at all, but I would say that the biggest difference is that because virtual threads are so cheap, when you need a scope, you just create it for whatever reason, for any kind of asynchronous computations you have to conduct. And as soon as this computation is done, you can get rid of this scope object, throw away all the virtual threads, and then create another one if you need another one. That's very different because an executor service is created along with your application and shares the lifespan of all your application. Okay. We saw the shutdown on success scope object. This shutdown on success will wait for the first task to complete, and when it has a result in the first task, if there's a result, if there's an exception, then it will wait for the next one. But if there's a result, then it will cancel all the other threads. It will interrupt them. All right. And the join method will return immediately, and you will be able to get the result immediately. There's also another object called shutdown on failure with a different semantic. The shutdown on failure will accept as many tasks as you need and will fail if one of these tasks is failing. So if you need, for instance, 3 computations and all of them are critical to produce your result, one of them is failing, will make your final result fail also, then you can use the shutdown on failure to do that.
Yeah.
You
and
cannot...
It will interrupt the other thread.
Yeah, it will interrupt the other thread also. Well, yes, it will do that.
Because there is no point to having them running anymore.
When I say you can extend, these 2 classes are final, so you cannot extend them. If you want to add behavior to them or modify the behavior, you can compose them, which is quite easy to do. But you can definitely extend, and this is what you just saw, the structured task scope class. I think it's meant to be extended, and the handle complete method to be overridden, and you can add stuff in it. If you extend that, this is what you saw. It allows you to implement your own logic and error handling in it. This is what you just saw. All the stuff is to implement this handle complete method to override it and to handle your futures one by one. I just would like to show you one last time this asynchronous pattern, which is once again a simplified version of the use case we just handled for you. Okay, this pattern is replaced by this one. This is basically the pattern you saw just a few minutes ago. I'm going to go back on this one. This is really callback within callback within callbacks, and you replace that by a code that is fully imperative, okay, that is fully synchronous, and that is executed in one thread. So that's much more simple, much simpler to handle, to write, and also to read. That's the code for the read weather, read weather for the weather scope. That's the code for the quotation scope, and you can see that basically, I think that writing it in that way, it's new API, so it's hard to tell which are going to be the pattern that you are going to use in your applications, but I think that these patterns are the simplest pattern you can imagine. And the third scope that we wrote was the travel page scope. So it's always the same pattern. It's always the same. And this is nice because it means that it's much easier to handle and to test and to get right in the first place. That's the handle complete method, which is the most complex method you can write. Well, that's not a very complex use case, but basically the handle complete method is not that hard to write. And these are the business method that you can add to your scope object and that we wrote together. You can also do thread dumps with a structured concurrency. Because doing a thread dump with millions of threads in it might probably be a little tricky to handle. So there's also an API to handle thread dumps. If you're currently doing this, you will have a nice JSON file with your scope objects. Do I have it? Let me check real quick if I have one, because I could show it to you. Yes, you cannot see that. Yes, I do have one, so I'm going to show one to show it to you. How can I share the screen again? Yes, that's the one. So that's the thread dump you will get. Okay, you have the process ID. That's the first element of the thread dump. You have the thread containers. Okay, these are the threads that are used by the travel page example. Okay, that's the first container, which is the structured concurrency stuff. Can I close them? I can't. I need to get rid. Let me go back to. Sorry. Let me exit presentation mode. Okay. So these are the different thread containers. And you see that the thread flock is in fact the Loom stuff. The thread flock is a public class. It's a class that is handling all the virtual threads launched by a scope object. So these are the three scopes that have been created. You can see that when I did this thread dump, it was calling this continuation.yield. These are the stack trace. You have the number of the thread, 24, 25, etc. 2 threads in this one, and you should have somewhere the container that is this guy, and the parent is root. Okay, so the parent is root, so you have all the structure of the scope that launched to which child scope, etc. That is present in this file. So with this file, I guess that IDEs at some point will be able to create some graphical user interface to show you properly all the threads that you have created in your application.
But as a tree and not as a
list. Yes, as a tree and not as a list. And when you have many, showing that in a structured way is probably much better. So the API is there to do that. What I did. Sorry. Okay, just a few words about this ExtentLocal variable. Sorry? Oh my God, you didn't. You're not working anymore.
You need to send some dollar to Microsoft.
Gosh. Okay, just a few words about this ExtentLocal variable. The ExtentLocal is in fact meant not to replace, but to provide another way to create ThreadLocal variables. ThreadLocal variables are used all over the place. It's stored in fact in a hash map bound to the thread that you created. So if you have 50 threads, you have 50 hash maps, and if you have 1 million threads, you have 1 million hash maps, which may be some kind of memory overhead. I mean, it's okay. Virtual threads are fully supporting ThreadLocal. So if you're running an application on top of virtual threads, a legacy application, and you have plenty of ThreadLocals all over the place, it should work exactly in the same way. Okay, but with ExtentLocal, the idea is to provide the same feature in a much more efficient way, memory-wise and also performance-wise. So it didn't make it to the JDK 19 as an incubator feature. It will hopefully make it in the JDK 20. That is in 4 months from now. The idea is, in fact, to create a context that is not bound to any thread, but that you can access from any thread of your application. I don't have any pattern to show you, unfortunately, but that's the idea. That's the idea. You create an ExtentLocal variable, you give it a value, and you can then query this value from any thread in your application. And depending on the context you are, you can have different values for your different variables.
Yeah, that's because currently there is no way to have the JIT to do some kind of magic with ThreadLocal, because if you take a look to the API of ThreadLocal, anyone can call set at any point in the code. So there is no way to optimize it. The ExtentLocal is a better API because it's linked to a stack. So if you are above a stack, you know the value of the ExtentLocal, and if you are below.
Absolutely. Any questions about what we saw? Yes, there's one there. You need to shout.
What would be the pattern to buy different transformation on a result set from storage? So let's say you want to fetch 1,000 records and then apply for each record several transformation. You don't receive all the records at the same time, and then you have to apply several asynchronous stuff, so that you don't wait for the 1,000, then do one operation on them, and then wait for this operation and do a second one. So what would be the pattern?
So the question is about the pattern. You have a bunch of records that are coming from a database, like thousands or tens of thousands of them, and you want to be able to process them as soon as they arrive, and you don't want them to arrive to process them all at once, once then they've all arrived. So that's some kind of map filter reduce that you want to do on this record, for instance?
So all pattern with then accept and things like that, but
Okay.
what about doing that in
So that's the if you have a you want to answer the question, Remi?
I think you're doing great.
No, no. Thank you. If you have a pattern with a completable future, it needs that every time one record is available, then you have some kind of signal that is coming. That is, you're not. If this is a complete, if you want to transfer this completable future pattern to a Loom pattern, and that can be done easily in the handle complete method, in fact, or in the main method of your scope if you want that.
Yeah. And I will add that the reactive API, not the implementation, the different implementation, but reactive API will not die because you can rebuild them on top of Loom, and you will get debugging, and you will get profiling. So, because basically what you are saying is something that you, the scenario you are proposing is something that is mostly a streaming things, and you can express it easily with a reactive API. What Loom provide is a better core to implement a reactive API on top.
So the scope could be shared in the handle complete so that you fork. You addition some fork into that and then you join once everything is done.
Yes, exactly. The question is, but it's a real question, which is, do you want to create a virtual thread per asynchronous call or not?
Absolutely. Does that answer your question? Yeah, thank you. Any other question? Yes, we have one here.
Are there plans to introduce virtual threads to other concurrent API, like parallel streams or something like that?
So the question is, are there any plans to add support for virtual threads in other APIs like parallel stream? For parallel stream, it would only add some overhead. So there's no gain to wait for that, because in a parallel stream, unless you're doing some kind of blocking computation in your parallel stream, but then you're really in a use case that you should get rid of, because you shouldn't be doing that, clearly. It has not been done for that. But there's no gain to expect from that. Yeah?
Yeah, you can still do it, because there is a little unknown API that lets you choose which pool you want to use for a parallel stream.
Yeah.
So you can use the pool of the virtual thread if you want. But if you don't do any blocking, you just add overhead. And if you are doing blocking and computation, usually you will not have great performance. So you will find a way to separate the blocking from the computation.
Yeah, question?
Yeah, so first opinion. So I find the code you showed more complicated than the...
So you're telling me that you're finding the code I showed more complex than the... You tell me that this code, you found this code more complex than this one.
So this code does more than the code on...
No, it does less. It doesn't do more, it does less. It only handles one quotation and one weather, and the other one handles 3.
Okay, so the code you showed in
No, I'm just arguing with you because I don't agree with you. I'm sorry to say that. Okay, that's your opinion.
Moreover, like the second thing, I find the async-await pattern more readable. So the question is, like, is it possible to implement async-await on top of...
So the question is, because you prefer async-await patterns, is it possible
I can
to implement
answer
that?
this one. It's easy. You already have async-await on top of it. You just create a method that does nothing. You call it async. You call another one that does nothing. You call it await, and it will work. You don't need async and await if you are able to copy the stack back and forth.
So the answer is you don't need async await. But if you like async await, you can just create the methods and call them. This is what you just said.
Yeah.
Okay. Are you happy with the answer? I suspect that you're not. Sorry.
And currently, mainly the main issue with async await is that if you have your code and you call something, and then you're blocking, all your chain has to be marked with async await. That's the main issue. It means that every library you are using has to be written using in the middle. Every library in the middle has to be written using async and await. And I think that the Java community has more challenge to play that rewriting the whole world using async and await.
Okay. I'm not going to ask you if you like the answer.
But in a way, if you take a look to Spring 5, the whole Spring 5 is about having the whole core having this async await thing. It's not async await because it's in Java, but being able to support the reactive API. So in a way, we have already paid the price for this kind of stuff, but only if you take a look on the server, like things like Spring, Quarkus, and Micronaut, and so on, but not on the other part, which are the libraries. So if you do things like parsing a special kind of format, you will not have asynchronous parsing. So you will rely on a puller thread and things like this. So your performance will go down. Even if you use the reactive API on the part of Spring, you still need Loom for the other part, which is talking with an API that was never written in an asynchronous or reactive way.
We had another question there. Yes?
On a very similar note, like I know I can understand probably that we don't want to change everything, and that's why we cannot do async await everywhere. But is it possible to do async await as an option for only the top level? So when maybe you rewrite the reactive libraries using Loom, you use the scope, and on top level, when someone uses these libraries, they are still able to use async await.
Yeah, that's the plan. That's
We
the
need
plan.
to-
Having a,
we need to
so
repeat the
I
question.
need to repeat.
Yeah.
The question was, can we have Loom on the basement level and build asynchronous or reactive API on top? Yes, that's the plan. Because you get debuggability and you get be able to profile your API.
Any other questions?
Nope.
Oh, yes, there's one here.
You told us about some of the pitfalls of the current implementation of Loom. Like if I have a stack of C in my Java stack, are there with you are interested in testing in the larger community?
So the question is about testing other use cases in a larger community.
Basically, yes. It's already an effort which is done by the community. We have demoed Spring 6 that already works with virtual threads. In the case of Netty, currently it's really hard to have Netty to move to virtual thread. Mostly because they are using ThreadLocals and native call that are in the middle of the stack. So if you want to contribute, go to the Netty mailing list and try to figure out with them how to implement it, how to implement virtual thread with Netty. I think it will be a huge step forward when Netty will be able to support virtual thread. I mean, it's already support virtual thread, but all threads are pinned, so.
That's not the goal, I guess.
Yeah.
Do we? Yeah.
Have you seen, so same kind of question, but about Tomcat, which seems to support virtual thread fully. Have you seen benefit in terms of latency and in terms of throughput using virtual thread instead of native thread?
So the question is, have you seen benefits from using a virtual thread from native threads in Tomcat, is it?
Yeah, and
I
yes,
didn't check
I
that.
don't think there is an official benchmark. I'm not doing benchmark because I'm stuck at it. But I know that several people have done benchmarks that show latency improvement using Tomcat.
Because it's still quite new, it's the big stuff in the JDK, so probably there are some cases that were worked around before and not.
It seems that Tomcat, currently JT and Tomcat seems to working very well with Loom. Because people have done the effort to make them work on the Loom branch first. So when it's integrated in the JDK, all the works is already there.
Elidan also announced the fourth version is a complete rewrite on top of Loom.
Yes, but
There's
the fourth version will be out next year.
Well, that's only in 2 months and a half.
I mean, next year in September or something like this.
You mean the first month of next year? Should be January. I think I saw a question there. Yeah?
Not a question, but just to say that I don't know about Tomcat, but there's a blog post of the Jetty team about how they tried the virtual threads. It's very interesting. It's a 2 articles blog post, and you can check it if you want.
So the comment is about 2 articles. I'm repeating for the recording that there are 2 blog posts written by the Jetty team about the benefits they had from using virtual threads that are very interesting.
Yeah,
Thank you for
the
that.
team was the first team to try to have a web server working with virtual
Exactly.
threads.
I think we have time for one last question, so you may be the last. Yes.
What things should I rewrite in my application if I want to replace ThreadLocal with Loom virtual thread executor?
You can use the factory method that we showed you in the executor service in the executors factory class. You have one particular method which is called new virtual thread per task something. And if your application is really based on a single executor service or just several executor services created in that way, you can just try to refactor your application with by calling this factory method, and then all the threads that you're going to use will be virtual threads. So you can see if it's still working and the performance improvements you may have.
And I also should get rid of all ThreadLocals, right?
Getting rid of ThreadLocals, for the moment, they will be working. They'll still be working because the virtual threads are compatible with ThreadLocals. Okay? The ExtentLocal API that we just mentioned is not available yet, even as an incubator feature. If you want to try it now, you need to go to jdkjava.net/loom and download the early access branch of the Loom project itself. Okay? It's a JDK 19 branch, so you will have all the preview features of the JDK 19, including the pattern matching we showed you. And then you will also have the ThreadLocal as it is now on this branch. But you can also wait for next March for the JDK 20, and ExtentLocal should be available in it.
And ThreadLocal is a problem more for frameworks than application. It depends on your application. But usually if you use ThreadLocal, you use it lightly. The problem is more, again, application, a server like Netty that store all his buffer in ThreadLocals. So you get...
Absolutely. And I think we have only 1 minute left, so that's just the time to thank you for your attention and wish you a great rest of the conference. Thank you.